Good morning, kids. In today's class, we are going to discuss about the horizontal projectile. Horizontal projectile motion. A very simple topic and very important also. So let's assume the basic condition. So let me have the tower. Now, what is the tower? Some cliff, tower, anything you can call it. So from here, we'll project a particle. So let this be a particle. I'm going to project a particle with the speed u, with the horizontal speed. So here what I'll be doing, I'll throw this particular stone ball horizontally. Then how the particle will move, what are the forces they'll be acting? The weight mg will act. Due to mg, then it will have acceleration along y-axis. So what is this acceleration? Mg by m will be g, and how it will be directed downward. So therefore we just show that because of the gravity and the velocity, the particle is going to deviate. So it's going to deviate and it will come and strike the surface somewhere at a point. Here the ball will come and strike it. It will come and strike the ground at some distance. Now, so let it have the velocity. At t equals 0, it was projected. At any instant of time t, let Vx be the horizontal velocity, let Vy be the vertical velocity, and the velocity of ball, let it be V. Let me choose this as origin. So then this distance will be x and this will be y, where this will be the position vector. What is r bar? R bar will be the position vector. We'll assume all the quantities which will be moving. What is this? This is the path of the ball. So how the path of the ball is going to move, instead of moving horizontally, it will move in a curved path, parabolic path. Already we have discussed. Okay, once again we'll revise it. Now this will be, we'll write the equation now. Along x-axis, x is equal to ux t plus x t square by 2. There is no horizontal acceleration. And what is the vertical acceleration? Equal to g. And what is the initial velocity along x-axis u, and initial velocity along y-axis is 0. Then how the particle, now equation, this will be u t plus 0 or x equal to ut along x-axis. If you look at the along x-axis, there is no acceleration. So ax will be 0. So we'll end up this equation. Along y-axis, y equal to uy t plus ay t square by 2. What is the initial velocity along y-axis? 0. It will be 0. Right, 0 plus this will be g. What is the acceleration along y-axis? It is equal to g, no? So therefore this will be g t square by 2. Now what is y is equal to g t square by 2. Let's substitute. X is equal to y equal to g by 2. This will be x bar so this is the equation for parabola, parabolic equation. Look at this quantity. How do this you look at only this, it is like similar to equation of y equal to x square. So what should be the path now? This should be a parabolic path. So what is the path of the ball now? We'll discover a parabolic path. So it's going to move in a curved path, a parabolic path, and will come and strike the ground with a certain speed. Now after this, I'm interested in to find out this range on the ground, horizontal range we'll call it. Then it will take some time to reach the ground. This is called as a time of flight. First, we'll calculate the time of flight. So what is the height it will descend? It will descend in a height h. So therefore, this should be equal to h is equal to uy t plus ay t square by 2. What is uy? Uy is equal to 0. Initial velocity along y-axis, it is 0. Then acceleration along y-axis. This should be equal to g t square by 2. So what is the time of flight? Time of flight is given by 2h by g. This quantity is called as a time of flight. Then what about the horizontal range? This horizontal range we have to calculate. So the horizontal range will be equal to r equal to ux t plus ax t square by 2. What is the initial velocity along x-axis? It was u t. What is the horizontal acceleration along x-axis? 0. There is no horizontal acceleration along x-axis. We'll indicate this clearly. Okay. Acceleration due to gravity. Now come for this one. This should be equal to ax. This should be g 0 t square by 2. So what is the range? Range will be now r equal to ut. So this is called like a horizontal range. Then it will come and strike the ground with some speed and let this angle be theta or phi. Call this Vx dash. Some other symbols will give. Now, how to calculate this horizontal velocity? The horizontal velocity everywhere will remain constant. This is something very important one, which I should indicate. The horizontal velocity so what is Vx equal to Vx dash equal to Vx dash should be equal to Ux, which is equal to E. The horizontal component of velocity of the particle will not change. It will remain constant. Any reason for that? There's no acceleration along x-axis. Vertical component of the velocity should increase with the time. The reason because of gravity, because of there is acceleration along y-axis. Okay, no. So we got what about Vy? Vy is equal to Uy plus Ay into t. This is 0 gt. Then what is the speed? Equal to Vx square plus Vy square. So this should be equal to u square plus dt whole square. So can we find out now this angle phi? This angle should be equal to tan phi should be equal to Vy by Vx. So based on that, so what is the tan phi? Yeah. Look at this triangle. I think I'll help you with this. So what is the tan phi? Vy will be gt and d. Like this. Like this, we'll get the angle made by the velocity vector when it is striking the ground. The angle made by the velocity vector just before the ball striking the ground. Okay, there's one background what student needed, a horizontal projectile, very important. So of all thing is, you should not forget this one. The horizontal component of velocity as that ball falls will remain constant. The vertical component of velocity will keep on increase. So like still some confusion. We'll have one small diagram. If you look at this is our cliff. This is a ball which will be projecting. Then how it will move? It will move in a parabolic path, a curved path. It will come and strike the ground. The horizontal component of velocity will not change. the vertical component of velocity will keep on increase. v1y, v2y, v3y. So here we can write like this: v4, v3 greater than. But horizontal component of velocity remains constant. Any reason for that? Because of this acceleration. Because of acceleration along y-axis, the vertical component will keep on increase, whereas there is no acceleration along x-axis. Hence, what we can write here. Hence, there's no acceleration along x-axis. So horizontal velocity will remain constant. There's acceleration along y-axis. So vertical component will keep on increase. This is a basic thing. And now what is this? This can be a ball, stone, any object. Usually will prefer a small body here so that you can analyze the motion clearly. And what is this path? This path should be a parabolic. Okay, kids. So tomorrow we'll continue with one more condition. In the horizontal projectile, we'll bring different cases. Okay, thank you all of you. Good morning, kids. In today's class, we are going to discuss about the projectile motion. In that, first we'll start with a basic topic called as basics of two-dimensional motion. So let's assume let me choose that this be the y-axis. Let this be the x-axis. So here, let it be x-axis. And let this be y-axis. Here I am going to choose a particle. This is a particle or ball or a stone, anything it can be. So let it be initial velocity. I'll give 3 meters per second. Let it have an acceleration AY equal to 2 meters per second square. How much acceleration? 2 meter per second square. So at t equals 0, let the particle be at origin. How do this particle is going to move? This is what we'll be studying. How do this particle will move under action of this initial velocity and acceleration? This particular background is there. Only acceleration we know, only velocity we know. If acceleration or velocity are in same direction, we know. No, but how they are perpendicular. How the particle is going to move, that will be studying. So the path of the particle will be, is going to describe a parabolic path. It's going to describe a parabolic path. It's going to describe a parabola. After some time, the particle will be somewhere here. But how do you can say it will be there only after some time? Now, if you look at because of initial velocity and acceleration, because of acceleration, the velocity along y-axis should keep on increasing, and there is no acceleration along x-axis. There is no acceleration along x-axis. So here, the velocity of particle will increase. In which direction will increase? Along y-axis, it will increase. Then after some time, let it be here. Let this be the y displacement. Let this be x displacement. Okay, these velocities I'll indicate here. This will have vx, this will have vy, and the velocity of particle, let it be v. Then this is at what time? At time t. At t equals 0, the particle was here. After some time t, the particle will be here. So now we'll write down the equation. So what is along x-axis? X equal to ux into t. Along y-axis, it should be equal to a1 t square by 2. Let me substitute the value of t here. Initial velocity of particle along y-axis, let's assume to be 0. So can we write equations of motion along y-axis? Then what is this? Equations of motion along x-axis as uniform velocity motion. So the distance course will be equal to speed into time. So let me substitute this equation. Y is equal to ay by 2. Okay, this will become x by ux whole square. then this should be equal to ay x square by 2ux whole square. Look at how y is proportional to x square. So definitely how the particle is going to move in a parabolic path. So what is the path of the particle? It should be a parabolic path. Or the path of particle will be a parabolic path. Okay, this is our primary equation. So this will tell us that this equation represents a parabola, so parabolic path. Then how to calculate the velocity of particle at any time? So velocity of particle should be equal to ux plus ax into t. So what is the value of ux now? Ux is, we assume it to be 3. This is 0 into time, 3 meters per second. What is Vy? Vy equal to Ui plus Ay into T. What is Ui? 0. Ay is how much? 2T. So can we calculate the speed of particle at any time T? Yes, we can calculate the speed of particle at any time T. So how much it is equal to? V is equal to Vx square plus Vy square. Vx square is how much? 3 square. Vy square is how much? 2T whole square. Like this, we'll get the speed of particle. Then it is going to describe a position vector is what I'll represent. I'll call position vector. What is this? This will be called as a position vector. So how to get the position vector? The position vector we can obtain r bar equal to xi cap minus yj cap. What is x is equal to ux into t? What is y? Y from here. Now, what is the value of y? Y will be ay t square by 2. Now substitute this value. This should be equal to ux is how much we assumed it 3t. Ay is 2t square by 2. So 3t minus t square. This is I cap g cap. I cap g cap. Okay, like this we can write this in the vector form 3t I cap minus t square g cap. Okay, this is a, what is this? This is a position vector. This is a parabolic path. This will be the speed of projectile at any time t. So all the quantities is what we are able to predict using this one. So this will give the position vector. And how the path, the projectile will move in a parabolic path. I think that's quite natural. No, you throw any stone, any ball, how it will move? Because of weight and velocity, it will deviate away from the velocity vector. Like this, we are able to predict the position vector, the path equation, and the speed of the particle at any time t. And if you look at this, this will make some angle theta. Can we calculate this theta? So this tan theta is equal to how much? Vy by Vx. What is Vy is equal to? Ay into t. What is Vx equal to Ux? So what is Ay? Ay equal to 2t by 3. With the time, what will the tan theta? Yes, definitely it will also vary. It will also vary. So like this, if the particle moving in a plane, so we are able to express. So now where how it is moving? It is not moving along nor along x nor along y. It is moving in a plane. No? That's why we are calling this as two-dimensional motion. So it will, instead of moving like this horizontally, the particle will deviate away from the path here. So there's one basic idea what we should have. So let's analyze further. Now, if the particle, there's a particle I had chosen. If it is having velocity like this, ui, and if you give initial acceleration along this direction, how it will deviate? It will start moving like this. This will be the path. Because of the acceleration and velocity, this will be the path of the particle. Okay, now similarly, if the particle is having velocity like this, and if acceleration is in this direction, how the particle will deviate in this direction. This will be the path. So what is this? This is called as a path. Similarly, if the particle, if it is having velocity like this, and if acceleration some direction like this, how it should move? So it's going to deviate this direction. A very general idea is what you should develop first. Then if particle is having velocity like this, it can have velocity in any direction, and let there be acceleration in this direction. Then how the particle will move? The particle will deviate in this direction. It will be a parabolic path and it will deviate. Sir, is it possible? Why you are taking acceleration in one specific direction? Why not some arbitrary direction? Okay, we'll do one thing. If there's a velocity, look at the acceleration, some arbitrary direction, then how the particle will deviate. It will deflect away from its velocity vector. It will deflect away from this velocity vector. So all this, the particle, when you subject it to velocity and acceleration, the resultant path will be a curved path. The resultant path will be a curved path. How to decide what is the specific path? By mathematical equations. Okay, there's one basic idea of the like a particle moving in two-dimensional motion. If the particle is subjected to both velocity and acceleration, okay, so then how you do this? Okay, fine. Now which velocity is greater? If I assume that ux greater than uy, how the resultant velocity will be? The resultant velocity of particle should be somewhere like this, and the resultant acceleration will be, let's assume that ay greater than ax. The resultant acceleration will be somewhere like this. Then how the particle will deviate. Okay, it's not that velocity like this. So a particle what will happen, can have acceleration in either of directions. In any direction, it can have velocity. The resultant path should be decided by the net velocity and acceleration. The resultant of the initial velocity and acceleration will determine how it's going to deviate. So first of all, what we should have a basic idea how the particle will move. It should deviate away from the velocity vector. Okay, so this is the a very general idea. So the things which will be widely using, suppose say here, let me give one more example. If I give velocity like this, and if there is an acceleration exactly opposite what will happen, there's a possibility, no? Then it will not be two-dimensional. Then what is the path of the particle? It will move, it will undergo retardation. It will undergo retardation and it will return back and will move like this. This will be the path of the particle. So when it will be two-dimensional, only if the velocity and acceleration are in different directions, then only the particle will go for two-dimensional. Then only the particle will go for two-dimensional motion. Already, I think you have come across if I give velocity and if there is a retardation like this, initially retardation, how the path of particle vertically projected, it will ascend, then descend. So when it will be two-dimensional, only when if the velocity vector and acceleration vector, if there is some angle, then it will be a two-dimensional motion. Okay, agreed. There's one a gross idea a student must have, and in all the things, if acceleration is constant, if this ax if a is constant, then we can take help of equations of motion to solve the problems. Okay, fine. So this is about the basic condition one must know before going for projectile motion. Okay, thank you all of you. So we'll continue. Tomorrow I'll come with another new problem, new conditions. Thank you all of you. Good morning, kids. We'll be discussing the effect of wind, horizontal wind on the projectile motion. So here this is the ball which we are projecting horizontal with speed u from a tower of height h. So that the tower of height h. Now a wind blows horizontally. There's a wind speed. So the wind will be blowing horizontally towards right, and the wind will impart an acceleration. So what are the forces that will be acting on the particle? The acceleration due to gravity, and there'll be also acceleration due to wind. Okay, these are the forces that will be acting on the wind, due to which there'll be an acceleration along x-axis. There'll be acceleration due to the wind, and due to weight, there'll be acceleration due to gravity. Okay, fine. So once again, I'll make you to analyze what is this AW. A wind will blow horizontally. The wind will exert a force. So sir, like a finding a little bit difficult, sir, what you are telling. Okay, let's assume there's a particle. The wind velocity will be act like this, and the weight will act here. What is the weight? Weight is mg. Then definitely it will get imparted with horizontal as well as vertical acceleration here. So what is the horizontal acceleration? Horizontal acceleration is given by Fw by m, and nothing but this is acceleration due to wind. Vertical acceleration is given by mg by m. So what about the wind? The wind will impart horizontal acceleration. Let me call that as AW. What about the G, AY? AY equal to, due to weight of the particle, there will be an acceleration. Okay, how the path of the particle? Now, due to the horizontal acceleration as well as the weight, the ball or the ball, particle, whatever be that, different objects it can be, provided the size of the object should be small enough. Now, what is the question like? What be the range in this case? What be the horizontal range? Then at t equals 0, it is projected horizontally. After some time t, it will come and strike the ground. So how the ball? Ball will move still again in parabolic path only. How the ball? The ball will continue in the parabolic path like this. So here the ball, it was imparted horizontal velocity. The wind will impart horizontal acceleration due to weight. There will be an acceleration due to gravity along y-axis. And the resultant path will be parabolic, and is going to move in parabolic path, will come and strike the ground at a distance r from the tower. Everything will be a tower. What are few questions like? What is the expression for time of flight, range, with what speed? Finally, the ball will come and strike the ground. And what is the angle? All these quantities will be finding out. So what is the acceleration now? What is the initial velocity along y-axis? 0. Along x-axis, it is this one. And these quantities are related to acceleration. I'll round it off. This will be, this data will be very useful for us. Okay, keep it aside. Now we'll begin like this. So let's apply the equations of motion along x and along y-axis. So for along y-axis, h is equal to uy t plus ay t square by 2. So what is the height it will ascend? Uy is 0, time of flight. In place of ay, what we have? It was g. T square by 2. So what is the time of flight? 2h by g. Then we'll calculate the range. This range has to be calculated. We'll apply equations of motion along x-axis. Then this will be range is equal to r is equal to ux p plus ax t square by 2. horizontal velocity imparted initially at t equals 0. It was equal to u. So right, this is u. Time of flight we know, 2h by g. Horizontal acceleration imparted by the wind, AW t square by 2. This is the expression for range. And what about the speed? With what speed it will come and strike the ground? Vx equal to ux plus ax into t. This will be u, AW, t. What is Vy? Vy equal to Uy, Ay into t. This is 0, gt. So what is the speed? Vector sum of horizontal as well as vertical component here. So what is V? The speed with which it will come and strike the ground, this quantity. So this should be equal to Vx is equal to how much? U plus AW. This T also, okay, we can substitute later. Dy equal to gt whole square. Okay, this is the expression for speed with which you strike. Then what about the angle? The angle given by tan phi equal to Vy by Vx. Gt by, so what is this angle phi? The angle made by the velocity vector with the horizontal. Now let's analyze what will happen to the components. Here V1x, V1y, V2x, V2y, V3x, V3y. Then with the time, what do we get? Vy greater than V3y, greater than V2y, greater than V1y. Then similarly, Vx greater than V3x, greater than V2x, greater than V1x, greater than U. Now, this is very important. Due to acceleration along y-axis, the velocity will keep on increase. Then due to acceleration along x-axis, the horizontal component of velocity also will keep on increasing here. Because of this wind, the effect of wind. If the wind blows horizontally, yes, we can use this condition. Okay, kids, we'll have tomorrow one more a new condition in horizontal projectile. Thank you, all of you. What are the, it was given horizontal velocity u at t equal to 0. Then the gravity will act and the wind will retard the motion of the particle, because how the wind is blowing? The wind is blowing towards left. Then how the path of the particle will be? First, it will move like this. Somewhere when it is moving, we'll analyze the velocity of the particles. The velocity of different particles. So here it will be at a different instance, we'll calculate the velocity v1x, v1y, v2x, v2y. Somewhere at one instant, the particle will be moving vertically, because the horizontal component of velocity should become 0, because the wind will retard the horizontal component of velocity. So somewhere at one point, the particle will have only the vertical component. Then again, the wind will continuously will try to impart the wind will continuously try to impart the acceleration. So this will further continue. So what do we expect now? How the particle will move? The particle will start moving and is asking that condition that let it come and strike the, okay, I'll give some other color. The particle will come and strike the foot of the tower. This is what some conditions asking now. We'll see like under what conditions the path of the ball will be like this. First, it will move in a parabolic path here. Then how the other motion of this particle will be? Here, what we can write, u greater than v1x greater than v2x. Along y-axis, v1y, let me write here, v2x less than v1x less than u. This will be motion along x-axis here. Along y-axis, vy greater than v2y greater than vy. So what is the type of motion here? Along y-axis, it will be an accelerated motion. Along x-axis, it will be retarding motion. Still, this will be a parabolic path. Somewhere at one point, at one instant of time. So we'll call this instant of time as t equal to t1. So from here, or we'll write some symbol, we'll take it a, let this be. At instant of time, tab, the horizontal component will become 0. The horizontal component here will become 0. Only it will have the vertical component. Again, the wind will continuously try to blow. Then the particle will move in again a parabolic path. So how the velocities will be here? Again it will have v3y, v3x, v4y, v4x, and finally it will strike it will strike the, let me, it will strike the tower. Okay, let the condition, let me put it vx, and let this be vy. Now we are just discussing a generalized case. So time taken to move from A to A, let it be TBC. So again, this will also be parabolic path. So this will be parabolic path. And this will be parabolic path. Now, what is the time taken TAB? TAB, what we can write here along x-axis, the equation will be from A to B, will divide this from A to B. For the path A to B, Vx or 0 equal to Ux minus AW into TAB. What the time taken will be TAB. Then what is Vy? Vy equal to Uy. Uy will be 0, Ay will be G. This will be Ux by AW. What is Ux? Ux is in fact equal to U only. And what is AW? Acceleration imparted by the wind. Acceleration due to wind. Okay, fine. Okay, this will be the Vy component or Vy dash. Same different symbol. Vy dash here will make it Vy. Okay, this one. Now, from B to C, what will be the conditions like? How it will be moving? Then it is undergone some horizontal displacement, no? Maximum horizontal displacement. Then can we calculate this xm? Xm will be how much is equal to 0 square minus u square equal to 2 minus AW into xm. So this is equal to, we have applied equations of motion along x-axis for this path. Then here it will be like this. What was the initial velocity u square? Final velocity along x-axis 0 square. Then how the AW is acting opposite initial velocity, so negative sign. And when it moves from A to B, what is the horizontal displacement? Xn. So we got this Xn. there's a maximum horizontal displacement, what it will. Then it should come and strike the foot of the tower. So what is the total time will take it? We'll calculate this one. Then again, it will get imparted. So it will acquire the same velocity here. Sir, how do you can say that it will have Vx dash should be equal to u only? You look at this one again for path from B to C, we'll apply the equation along x-axis 0 square Vx dash square minus 0 square equal to 2AW xm. What is xm equal to? U square by 2AW. So what is Vx dash finally equal to U? So with the same horizontal speed, it will come and strike. But here it will be striking somewhere in this direction. So can we calculate what is Vy? For that, I think we need a time BC. How to calculate time BC? Yes, we can apply the formula Vx dash equal to 0 plus AW PBC. Vx dash is U, AW PBC. What is the time taken to move from, again, B to C will be same thing. PAB should be equal to TBC. Now we can calculate Vy dash. Okay, now Vy dash. Vy dash is equal to Vy plus AY into TBC. Vy is how much? We have calculated this GU by AW. AY is G, TBC is U by AW. This is equal to 2UG by AW. Finally, with what speed it will strike? It will strike with a speed up to all these quantities. U square 2GU. Let me move this a little bit. Okay, fine. So there's a one basic idea. If a ball is projected, first what will happen? It will undergo accelerated motion along y-axis, accelerated motion, along x-axis, retarding motion. Now, what about this path? This path will be accelerated motion both along x and along y. So we will write the important data. Now, what is the data here? V1 u greater than V1x greater than V2x. Then again here Vx dash greater than V4x greater than V3x. Look at this. With this, you can really conclude anything. So now further we'll write here Vy dash greater than V4y greater than V3y greater than V2y greater than V1y. Look at this data. Along x-axis, first it will undergo retardation, then acceleration. What about along y-axis? Continuously accelerated motion. So if the wind blows towards right, okay, this is what the condition. If the wind blows horizontally towards left, there's a possibility that the projected ball will come and again strike the foot of the tower. So here, there's the foot, there's a top. So from where we have projected the ball? From the top of tower. Where it is coming and striking back? Where it is coming and striking it? Foot of the tower. So this will happen if the wind blows horizontally towards left. Okay, fine.